Good morning to all of you. Uh, Today's topic it is a JFET and LGT. Last class, what we discussed about a diac and triac, right? Diac is a two-terminal, three-layered semiconductor device, whereas a triac is a three-terminal, four-layered semiconductor device. So both are current controlling devices only. We discussed about the characteristics of that is the VI characteristics of diode, diac and triac. Diac means di and AC means alternating. That means it is regulating the alternating current. Uh, it's maybe the triggering off and on like that. Uh, uh, we can use this at both diac and triac. Diac in this die that is two diodes we are using in these two diodes in bidirectional. That means both are means it acts as a forward bias as well as a reverse bias. So both this diac and triac is also a bidirectional device. That means it works in forward bias as well as in reverse bias. Same similarly in the what we discussed in the characteristics of VI characteristics of diac and triac. We discussed in the first quadrant and third quadrant. That is the first quadrant indicates forward bias and third quadrant indicates reverse bias. So that means this diac and triac both are working in two modes, that is forward bias and the reverse bias. That means so that's why you can call it can call as a bidirectional device. Bidirectional, that means the diode the polarity changes. Here the two diodes are there. In diac two diodes and triac is also two diodes. But in the triac another terminal gate terminal is there. This gate terminal is to control the current, right? And these diac, triac, and some other silicon controlled rectifier, silicon controlled switches. So these are belongs to thyristor family. There are so many switches are there, but not required in our syllabus. So we have to concentrate on diac, triac only. No, don't concentrate on the SSCR, silicon controlled rectifier and thyristor, right? So in the syllabus, it is a diac and triac only. Now we will discuss about JFET and LED. JFET, it is nothing but in the field effect transistor. I informed to you the classification of field effect transistor is two types. That is first one is a junction field effect transistor, that is JFET, and another one is MOSFET. Already we discussed the MOSFET. In the MOSFET already this that MOSFET it works under the principle of capacitor, right? That means gate plate is there, another N channel plate is there. So in between these two plates, one metal oxide layer is there. That metal oxide is nothing but a silicon dioxide layer. This acts as a semiconductor or dielectric in between the two plates. Thereby the polarity changes. But here in the JFET, no metal oxide layer. Without metal oxide layer, the function is same as it is. So now we will discuss. See here, this is a JFET. Right. N-channel JFET, it is composed of N-type body and P-type gate. The N-channel JFET, it is composed of junction field effect transistor. This one, once if you understand the previous classes with thorough the fundamentals, this one you can easily understand. You can easily understand this one. And N-channel JFET, it is composed of N-type body and P-type gate. And here the gate is generally reversed bias to control the current. Means the flow of the current is to be 1 minute annotations. Reverse bias it is to control the current flow. If you see it here at this is in the MOSFET three terminals are there, right? So what are the three terminals? A gate, a source, and a drain. Same similar in JFET is also. So here this is gate. This is gate, right? And this is around that one, and this is source, and this is a drain, right? Uh, Here, if this is the JFET symbol, N channel JFET symbol, it is N channel JFET. Here, the gate is the common to both the source and the drain. See here, for the connection is from here the gate, and then see here the connection, and here from this the middle of this it is to source. Let's see here. If you see clearly, this is field effect transistor. So now we will go for next one, JFET construction. This is N channel FET. This is N channel JFET. See here in this this is the construction. Yet here this side P type is that one only we discussed in the previous in the N channel MOSFET. That is see here in the N channel MOSFET, N type body and P type gate. Here is written clearly, N type body and a P type gate. That means here see here P type gate here. See, this is a P-type gate. Here, the P-type is connected to the gate. The P-type is connected here, and this is the N-type body, right? From source to drain, the N-type semiconductor. This is the N-channel JFET. Whereas in the case of the P-channel JFET, see here, this is a N-type gate. Whereas in the N-channel JFET, it is a P-type gate, but here it is N-type gate. And the body is P type. And the body is P type here. So that's why it's called as a P channel JFET. The body is P type, and here for the gate is N type, N type gate. So this is the construction. You have to observe clearly. On the gate side, P type semiconductor is there. That is called N channel JFET, and the total is N type. N-type semiconductor, but here in the P channel JFET, the gate is N-type and the body is P-type. So the next we will go for the next one. We'll go for the next slide. Now we will discuss the P channel JFET. So P channel JFET, right? See here in the meaning itself only we can understand the P channel JFET. P channel, that is the majority carriers are holes. The body is in P type, and the gate is connected to the N type. Then see here, if you supply the gate to source voltage, negative gate to source voltage to the N type. So here what happens, negative terminal is connected to the N type, and the positive terminal of VGS is connected to the P type. That is source. The S is indicates source, and this is a drain. This is a drain. Here this is drain. And if you see, observe clearly, so what happened? The negative terminal is connected to the N type. So N type is nothing but that is all are negative, right? Negative, right? And this is positive is connected to the P type. That means positive means holes, right? Positive means holes. Positive charge. So here, what happens here? Negative is connected to the negative, right? And then here, mm, in this positive charge is increased. Positive charge is more in this case. The positive gate bias voltage is increased, and the P channel increases. That means here the body increases. That means the here the body is main is of p-type semiconductor. So thereby the decreasing the current flow in the circuit. The current flow decreases automatically. The current flow decreases in this case. So because p-type is completely the body, but just it is controlling. That means the current flow in the circuit is decreasing. Why? Because the majority carriers are producing that is holes, that is positive charge. Of course, current is there passing due to this gate, N-type semiconductors. A negligible amount of current is flowing in the circuit. That is at VDS. VDS. This is VDS, right? Negligible amount of current. That means here the current flow almost all decreases in this because it is a p-type body and n-type a gate. And similarly, if you go for the next one, if you see, this is n channel. In the n channel, the JFET, here the body is n channel, that is n-type semiconductor, right? N-type. See here, this is n-type, and here the gate is a p-type. That means here if you increase the VGS, the voltage, VGS voltage, automatically what happens here, the negative charges increases here both n side. That is, of course, maybe here the holes it attracts and then it passes, right? So thereby here the current increases. If you see clearly, this is the n channel JFET electron current flow from source to drain, because the body is n type body. N channel JFET is the body is n type semiconductor. So here the current flow rate increases. The current flow rate increases. So thereby the N channel JFET is the flow of current increases. That means it works under only in the forward. Remember this point. That means once the current flow increases, will take place in only in forward bias. The current flow decreases means that is in terms of milliamperes or microampere. That is in the reverse bias. That means negative. So here N channel JFET is electron current flow from source to drain increases. There will be a much more increase because here the negative charge is developing more, right? Right. Here I already told you the gate is a controlling unit. So here the depletion layer actually decreases. That means this p-type will be decreases. So why? Because so this p-type is attracted towards the negative. So thereby the majority carriers are electrons. Majority carriers are electrons. The next we'll go for the next topic. Light emitting diode. If you see this light emitting diode, all of you know very well. Light emitting diode. The diode emits light. That is, the diode it is emitting radiations. See here in the light emitting diode, it converts electric current into light. That means here, if you observe this electric current into light. So light emitting diode, the diode is emitting light. Here in this light emitting diode, it works on the principle of that is forward bias in a PN junction. That means in other words, it is a PN junction diode. LED is a PN junction diode. It works under only the forward bias. No reverse. That means it is not working under the reverse. It works under forward bias. Light emitting diode. Here the wavelength of emitted light is fixed for a material and it depends upon the energy gap between the conduction band and the whole energy. So here the wavelength of emitted light is fixed for a particular material. and it depends. That means the material changes automatically. The wavelength of the emitted light, that means the color of the light changes. If you clearly observe that in the PN junction, right, the wavelength in the PN junction, that means it in the like PN junction. Here the emitted light, right? Here the light is emitted. It is the wavelength of the emitted light varies with material. And for example, if you see in a LED light emitting there are different colors. That means having different wavelengths. Particular here the material changes. That means it depends upon the energy gap between the conduction band and the hole energy. Conduction band. That means a gap is there between the conduction band and hole energy level, right? This one actually not required. Of course, uh, and then next, if come to here, LED, this tends to more efficient in lighting applications compared to the ordinary light bulbs. That means that convert a heat into a black body ratios, most of which cannot be seen with by the human. It's very difficult. So that means this LED is the small light. For example, if you clear, it's to see that light emitting diode. It's very difficult. See here in the figure, if you see uh, that radiations will be more. Uh, that means that converts a heat into black body. Then correct. Then this is a light emitting diode. If you see the inside light emitting diode clearly, if you see here, these are the two terminals. See here, these are the two terminals, terminal pins, and this is the transparent plastic case, and this is the diode, right? Diode and emitted light beams. These are the emitted light beams from the diode. So coming out. So these are the emitted light beams, right? So actually, this is the arrangement inside the small bulb. If you see, uh, even in our household appliances, in each particular every room, one small red light in that the beside the switches, it is blinking right around. So that is nothing but LED. If you see that, you can clearly observe the LED. Right? That is the red color. Say, example I am saying, right? If you see the red color, that it is shielded with a red plate, and then inside a small bulb is the right. The small bulb that is a LED light emitting diode. It indicates so here what it indicates the current the light that LED light glows means the current is passing into that particular room. If the light is not glows means what happened, then the current some fuse will be disturbed. That means gone, right? That fuse is gone like that. So in LED, the applications are so many applications are there in LED. The LED, if you see, even in our traffic signals, we can use that LED light. And for example, now the watches are coming, smart watches, right? There, the light is there. When you switch on automatically, we can see that how much time is there, right? Uncle? So inside LED light is there, right? LED bulb, small light emitting diode is there. There are so many examples are there. This about this LED. Then see next one. See here in LED, here when the current flows across the diode, so negative electrons move one way and positive holes move another. See here, this is the negative. It moves in one direction. It is blue color, completely blue color, and this is a red. the positive is moving in the opposite direction. That means this both the current flows across the diode, that is negative electrons move in one way and positive holes move another. If you see clearly observe, this is for example, this blue color is completely p type in the upside, is p type, and this negative is completely n. That means it is a p-n junction diode. This is a p-n junction diode. P is positive and n is negative. Already we discussed about the p-n junction diode. That means here positive, that means holes is moving in one direction and negative is moving in another direction. See here, so the negative is moving in this direction, the positive is, that means in opposite directions, both are moving. Why? Because both are attracted. So thereby what we discussed in the BN junction diode, again, we have to remember the principle of PN junction diode. Here, this is same PN junction. It is PN junction. Here, this is a junction. If you consider, it is visible to you. I am drawing here. It is visible. Anybody? Let me know. Otherwise, I will change the color. This is P type, right? P type means holes. Anybody can respond in the chat box. And this is N type, right? The PN, both are, that is sandwiched. PN junction sandwiched, PN junction diode. And then here a P type is a positive, that is holes, and electrons are negative, that is N type semiconductor. So here the P positive charge is moving in one direction, that is in this direction, and negative charge is moving in this direction. That means here the depletion layer decreases. Remember this point. Here depletion layer decreases. What we discussed there, I am drawing here. All of you listen carefully. This is actually PN junction diode, right? PN junction diode, right? Correct. And then some gap is there between this. That is called depletion layer. Once the positive electrons flow in one direction and negative electrons flow in the opposite direction, that means attracting to each other. Thereby, what happens? This depletion layer will be decreases. What it means? The depletion layer increases means the current develops. So remember this point. The current develops. So the current flow. That means once the depletion layer region decreases its width, then automatically the current flows in the circuit. Once the current flows in the circuit, who can get the output? Similarly, this complete thing, this is a PN junction only, this complete thing. If you see the positive is in red color and negative is in blue color, right? So both are attracted to each other. Both directions are, and then thereby the depletion region decreases. That means indicates the current is flowing. That means, for example, if the depletion layer is increases means the current flow decreases. The current flow decreases, right? That is in reverse bias. But in the forward bias, the depletion region very less. Almost all. That means the current flow in the circuit. There is a current flow. That means current is increases. Once the applied voltage across the PN junction increases, thereby what happens? The current is also increases. The next, come to the next slide. So here, this is the practical what is happening inside LED. What is happening inside LED? That means to see clearly, light emission. Say this is a PN junction. This is a P and PN junction diode. Here, see these N type electrons are there. These are the complete electrons, and P type is holes. And here, what is happening in LED, light emitting diode? and these are two are connected to the terminals, right? Electrical contact. These are electrical contacts. Then the typical LED needs a PN junction. What we discussed is a PN junction for LED. PN junction forward bias, and there is a lot of electrons and holes in the junction so to excite. Here, what is the junction? This is the junction. Here, this is the junction, right? This is the junction. Here, this is right. This is junction, right? Here, there are a lot of electrons and holes at the junction due to excitation, and electrons from N side to be injected to the P side to promote recombination. That means here what is happening, electrons from N side need to be injected to the P side, that means attracted towards P side. That means to promote recombination, right? And then the junction is biased to produce even more electrons and holes. EH means electrons holes. And to inject electrons from N to P and recombination to be happen. So this recombination produces light, recombination. So here positive to electrons, positive to negative, negative to positive. Here the recombination. So recombinations produce light. So that is what I said, that depletion region decreases. Thereby the electrons flow. Once the electrons flow, at this situation what happens, small light will emit. Small light is emitted. Small light, small light. This is the principle actually. Small light is coming out. That is called light emitting. The diode is emitting light. The diode is emitting. What diode it here? It is a PN junction diode is emitting light, or PN junction diode is emitting radiation. And see here that recombination of what is the recombination here? N to P. That means N to from N to N type semiconductor to P type semiconductor. The next, if you see, so all are listening. So I will ask one question, right? Number 331, better mute. 331, 331, mute. Unmute. 331, please unmute. 331, regular 331. Regular 331. I am asking about regular 331. Is there or not? He is 331. 331. Regular 331. Okay, mute. Unmute yourself. 331.
Yes, sir.
Okay. So now this light emitting diode, it works on principle. Can you tell? What is LED?
Light emitting diode.
Light emitting?
Diode.
Speak out. Light emitting?
Diodes.
Okay, right. So now can you tell the functioning of LED? LED. Babu, speak out. Number 31. Number 31.
Sir.
Cheppu nanu. Number 31. Speak out.
And
వినట్లేదా?
like that. Yes.
Can you name the diode? Functioning of LED. It is a PN junction diode, right?
Yes.
And then it works on forward bias only, right?
This is semiconductor device.
Ah, okay, right, correct. Speak out. It is a semiconductor device.
That emits
Right.
light. That emits light when current flows through it.
Mm. Current in which way it flows? So
Semiconductor light
from the
source.
PN junction diode, the current developing of current. Can you tell the function of PN junction diode? Okay, next number lateral entry 12. Mm, Lateral entry 12. Lateral entry 12.
Yes, sir.
Uh, can you explain about PN junction diode? Function of
Hello.
PN junction.
Sir.
Speak out, Amma. Number 12, lateral entry. What is your name?
Harshvardhan, sir.
Chepamma.
PN junction diode controls the flow of electric current in a circuit.
Flow of?
Electric current, sir.
Okay, right. In a PN junction, uh, uh, that means majority carriers are PN junction diode, forward bias. Majority carriers are, what are the majority carriers?
Majority, sir.
Uh,
Hello.
Chepamma.
Sir, P type.
PN junction diode, forward bias. I'm asking about forward bias.
Sir, forward is P type. Positive majority charge
Forward
carries.
bias,
Positive majority charge carries.
majority charge carriers are
Positive, sir. Positive, sir.
positive. PN junction, forward bias.
Yes, sir.
Huh? Forward bias, right?
Yes, sir.
Correct? Anybody can oppose us what he said the sentence. Otherwise, anybody can object. Otherwise, if it is correct, if it is correct, okay. And anybody can object his sentence. You can speak out. Anybody. It's just a discussion. This is. So he said one sentence, right? He said one sentence. Here, what he said that in PN junction diode, forward bias, the majority carriers are holes. He said. Anybody? Anybody? Please message chat box so that you can unmute yourself. Number, anybody. Otherwise, we are accepting what he said.
Sir, external applied for. Sir, external applied potential force majority carries in PN junction forward bias.
Babu? Babu.
Sir,
Hmm.
potential force majority carries in PN junction forward bias.
I'm not getting your voice properly. It is disturbing.
Hello.
మా చెప్తున్నాను వినపడుతుంది ఇప్పుడు.
Sir, potential force majority carries in PN junction forward.
I'm not asking about that.
Yes.
Simply, you said in the PN junction forward bias, what
Okay.
are the
Yes,
majority
sir.
carriers? So explain. For example, you said that it is holes.
Yes, sir.
If it is holes means the positive charge is increases. How can the current flow is very less, right? The majority carriers are holes. Then what happens? The current is very. That means very less. The current flow is very less, right or wrong?
Yes, sir.
The current is flow is very less means that is coming under reverse bias, not in the forward bias. Yeah, already I clearly explained you in the see here. This is graph. In the PN junction, the graph is like this.
Sir, voice cut అవుతుంది సార్.
It is like this. So now it is voice is see here. Now it is clear. Voice is
Yes, sir. Yes, sir.
this is a positive. This is forward bias, right?
Yes, sir.
And this is a reverse bias. See here. In the reverse bias, see here. This is a completely. This is a negative. This is a voltage, and this is current. That means x-axis is voltage, y-axis is
Correct.
current. Here, when you apply the positive voltage, automatically the current increases. Right? In the far, what I
Yes, sir.
am saying, in the PN junction diode, forward bias, the majority carriers are electrons.
Yes, sir.
Electrons means current. The current increases. But in the reverse bias, see here the current, this is the negative voltage, and this is the negative current. That means the negative current develops.
Yes, sir. In
Negative
the worst
current
way, circles.
means current developed is very less. That is in terms of milliamperes and microamperes. That means
Yes,
the
sir.
current flow decreases in the reverse bias. Whereas in the forward bias, current flow increases. So here this PN junction diode works under the principle of uh, that means PN junction works under forward bias. In the previous slide, I clearly explained you. See here in the previous slide, in this slide, I clearly explained LEDs. Uh, see here, the LED light emitting junction based
Yes,
on
sir.
PN
Under.
junction under forward bias.
Yes, sir.
Under forward, but you are saying that holes, Babu. You are saying that holes. Forward only the current develops.
Yes.
That means the current flow increases. Once the applied voltage across the terminals of the PN junction increases, automatically the current flow increases. Once if the
Yes, sir.
due to this current flow, the recombination, what I said in that principle of LED, recombination of then EH, that means electrons and holes, thereby the light is emitting from that particular material.
Okay, sir.
1 minute. Okay, clear, Nana?
Okay,
Clear?
sir.
Okay, okay, Nana. Mute. Okay. Now, all of you understand, right? Any questions? Here, once if online means we are not able to see all of you. So better concentrate on as what the lecture said. So don't uh, sit simply. Huh? And then if you come to here, there are so many applications are there. See here, if you see here, in this, hmm, see here, this is time for LED bulb and for traffic signals. And for example, in sports, if you see in the sports, for example, uh, here the name is there, right? Here the names. So backside LED bulbs are there. So with the help of the LED bulbs, so from there are small holes. For example, P is there means like these small holes are there, right? Each and every hole. See here, this is P example. The design should be like this. Each and every hole, it's one LED is there, right? See here, for example, here N. N means small holes are there. Each and holes, one bulb is there, LED bulb. So with the help of the LED bulb, we can clearly visible the name. That holes are there, right? See here, for example, here I am writing P. This is P. Example, see, and each and every hole LED bulb is there, right? Then railway timings, yes, railway timings, right? If you see in the railways timings, and these are all see here, even in the see here yet here, if you see this the marking, one person said the railway station boards, right? Very good, railway station. So these are all LEDs here. Those are the digital LEDs, right? Automatically the name is displaying, and then like that, name display and the number of that train number displaying. These are all LEDs with the help of the LEDs only. And any other example in LED? Anybody? Somebody are posted two applications. Anybody? Just you can post the applications of LED, light emitting diode. That means the diode is emitting light, or the diode is emitting radiations. That means here what I said, that electric current is converting into light. Digital wall clocks. Very good, very good. Digital wall clocks, right? LED. Next. So many applications in our daily life we can see in so many. Even if you see, for example, in ovens and ovens and also in electric pressure cookers, electric cookers, right? The rice cookers. These are here the light. For example, if the cook is some yellow light will close. So these are the change. The light changes automatically. Is another one. Digital wall clocks, watches, right? Very good, watches. Next. And see, if you see camera, right? If you see, for example, in the camera, our cell phone camera, you forgotten the main thing. So members with the help of the cell phone, they are taking the snaps, right? That is nothing but LED, right? Light emitting diode. It's a flashlight, right? Okay, electric stove, right? Very good, right? Electric stove. Uh, Correct. Electric stove, right? In electric stove, if you see, for example, prestige electric stove, there in the beginning, so all the bulbs, for example, the cooking, the cooking, for example, dosa, and for example, curry, and some light is there, right? So when you automatically, with the help of our finger, when you press the automatically, that light glows. So these are all LEDs are arranged. And then LEDs, what is TVS? Automotive headlamps, very good, correct. Automatic light. See, for example, even I'm speaking now in front of a desktop, one camera is there, right? That camera, four LED bulbs are there, that is focusing on me. That camera, around that camera, four LED bulbs are there, four LED bulbs. So there are so many applications in LED. Another one is a projection lamp, right? With the USB cable USB port, you can go for a projection of small lamp. Already it is very cheap. It is around 40, that is below 100 only. And for example, even if you see in kids small boxes, in the kids small boxes, for example, the current is of a small LED bulb, the glowing is very bright glowing. So automatically, with the help of that lamp, we can study, right? And then water heating is right, very good. Water heating is like here in the daily life we seen so many. What he said, it is correct. Water heating geysers, right? There are three colors are there: the yellow, green, and red. Am I right, Mr. 335 lateral entry, Mohan Sai? Green, red, and yellow. Three marks are there. The three marks are glowing. That is indicating that is the heating is much more or heating is less, like that. Right, right, right. So water heater geysers, like that. LED, almost all wide range of application. Wide range of application. Even if you see, for example, our CPU, or if I press on the CPU, automatically light close. Maybe green light, right? Right or no? Correct? Or otherwise some red light. It indicates that is on. Indication that is gives, it indicates. Anybody? So network problem has been Sheikh Mastan. So what is your roll number? So I will take the attendance. Now the time is over. Here, if going on discussing like that, there are so many examples are there in our daily. Okay, now the one by one, the time is over. 5 minutes. So all of you write the quiz. Only last quiz also only 60 members written out of 130. This is not good. It takes around 1 minute to come. 11 o'clock it will opens. Right. Okay. We have to respond at least one by one. Post in the chat box. Number one, 4, 4, 4, right, 5, 5, option 5, option 6, 7, 7, 8, 9, right, 10. Okay, 8 is 10, 11, 13, 14, 15, 15, 16, 17, 18, 19, 20, right, 21, 22, 23, 24, 25, 26, 27, 27. One person written that digital meters in motorbike, right? Motorbikes, correct. 28, right? 29, 30, 31, 32, 33, 34, 35, 36, 37, 37, 38, 39, 38 option, right? 39, 38 present, 40, 41, 42, 43, 44, 44, 45, 46, 48, 49, 48, 48 options, right? 50, 52, 52, 54, 52 option. 55, number 43 telling that LED display TV, right? Okay, correct. LED display, right? Red, green. That red indicates it is in off condition, green indicates it is in on, right? 52, almost all LEDs, almost all wide range of applications are there. 55 present, okay, right? 56, 56, 56, the next 60 present, okay, 61, 63, 64, 65, 66, 66, 67, 68, 69, 69, 70, 73, 73, 74, 75, 76, 77, 78, 79, 78, 79. Okay, right. 78, 78 option, right? 17, 80, 81, right? 81, 83, 84, 84, 83, 84. 84 present, okay, right? 83 option. 85, 88, 89, 90, 91, 92, 1, 2, 2, right? 3, 4, 4, 4, 5, right? 6, 8, 6, 8, 8, 8, 9, that entry 9. Okay, right, present. 10, 11, 12, 13, 12, 12, 13, 14, right, 15, 16, 16, 17, 18, 19, 21, 22, 22, 23, right, 24, 25, 26, 27, 28, 29 present, okay, right. 28 is also present. 30, 31, 27 at 28 option, right? 28 option amma, 28 present kadam, right? Latent 28 present. 1 minute, don't 29 present amma, latent 29. 1 minute. Lateral 29 present. 30, 27 is present, okay, right. 30, 30 option, 31, 32, 33, 34, 35, 36, 37, 37, 38, 39 present. Okay, 40, okay, 27 present, lateral 27 present, 39 present. And then next 40, 40, number 40, 41, 43. Three members are option: 40, 41, 43 option. 41 present, right? 41, 43 present. Number 40, number 40. So now I read the options. Just listen. Number 5, 7, 9, 10, 48, 52, 56, 61, 66, 83, 70, 85 present. Already given present. 78 is also present, right? And lateral entry 1. Again, I am reading. All of you listen carefully. 5, 7, 9, 10, 48, 52, 56, 61, 66, 83. And lateral entry 1, 16, 17, 18, 25, 25, 26, 30, 31, 38, and 40. 18th batch 18 present. No? Okay. 17th batch 66. Okay. No, already present. 370. I see the lateral entry 2 came, but he is not there. But and 337. Okay, 337 present and 317 present. Okay. Again, I'm repeating. All of you listen carefully. 5, 7, 9, 9, 5, 7, 9, 48, 52, 56, 61, 83. Lateral entry 1, 16, 25, 26, 30, 31, 38, 40. So these are the options. Okay, right. Thank you, all of you. So now compulsory you have to attempt the quiz. Lateral entry 1 present. Okay. You have to attempt the quiz. Today I will check. Otherwise, I will take the severe action on you. Compulsory 113 students means 113 students have to attempt. Right? So today almost all 95 members came to this class, 95 to 99. Only 15 members are absent. So you have to be attempt compulsory. Almost all those who are attended today's class, you have to attempt this compulsory within 1 minute. Thank you.
It's not fun.